Hi, welcome back. I am Nisha. In the last session, we discussed about selection sort. Sort means arranging elements in an ascending or descending order. So today we are going to discuss another method of sorting, that is called bubble sort. So why bubble sort? How the name bubble sort? Because the larger element, the larger value or data of that array bubbles towards the top of that list. That's why we are calling it as a bubble sort. So let's see how we can do that bubble sort in C++. So what is bubble sort? Here I put some important points and the logic. So declare an array first and accept all the elements into that array. That is the first point. Then the second one is the main important logic of this bubble sort. Compare each pair of adjacent items. We want to compare the adjacent cells and swapping them if they are in the wrong order. Swap means we want to exchange the elements if they are in the wrong order. Understood? We want to compare two adjacent cells. For example, if 10 elements are there, first we want to compare the 0th one and the first one. If it is not in order, swap that time itself, exchange the value, exchange the position of that values. So that is bubble sort's main logic. So this passing procedure is repeated. We want to repeat this process until no swaps are required. That means it indicates that the list is sorted. If there is no swap means all the elements are in sorted now. Understood? This is called bubble sort. So we want to compare each pair of adjacent items, means adjacent cells. And if it is not in order, we want to swap it. We want to swap it means we want to exchange the values. So here I'll show you one example. Here the example is ARR is the array name, 10 is the size of the array and only 5 elements are there. It is not in proper order, so we want to make it into ascending order. So in bubble sort, first we want to compare adjacent cells. Adjacent cell means here 0 and 1 we want to compare it. So 10 and 7 we are comparing. So it is not in order. So 7 we want to move to the 0th position and 10 we want to move to the first position. If it is not in order means we want to swap it. So swapping means what? We want to exchange the values. Okay. 7 we want to move to the 0th position and 10 we want to move to the first position. So now the first adjacent cells comparison is over. Now this we want to move to the second one. Second is 1 and 2 we want to compare it. Index number 1 and index number 2. 10 and 12 we are comparing. Okay, but it is in order only. See, 10 is the smallest one comparing with 12. So we don't want to swap it. So we can keep it in the same position itself. Now the next is 2 and 3. So 12 and 18 we are comparing. So 12 is the smallest one here and 18 is the biggest one. So this one also in proper order. So we don't want to swap it. So 12 is on the second position itself and 18 is on third position. Now the next is 3 and 4 we want to compare it. 3 and 4. So 18 is on third position and 3 is on fourth position. So here this is not in order. So 3 we want to move to the third position, then 18 we want to move to the fourth position. So swapping. So now it is swapped. See the values now? We exchanged, is it? We bubbled the highest element to the ending, the top of the list. So 18 is the highest element here. So 18 came at the last position of that array. Okay, so 1 passes over here. So we got the highest element at the last position. Now again we want to start. It's not in sorted order. Only 18 is in sorted. But 0 to 3 elements are there to sort. So again we want to sort it. 7 and 10 comparing, adjacent cells comparison. So 7 and 10 we are comparing. It's in order only because 7 is the smallest one and 10 is the highest one. So we don't want to swap it. Now next is 10 and 12, we want to compare it. So 10 is the smallest one and 12 is the highest one. So this one is also in proper order. So we don't want to swap it. Then 12 and 3 we are comparing. 12 is the highest one, 3 is the smallest one. It is not in proper order. So we want to swap it. Is it? We want to swap it. 12 we want to move to the third position and 3 we want to move to the second position. So swapping. Now swap over. Is it? Now we got the second highest element. See, 12 is the second highest element in this unsorted list. Okay, now second pass is also over. So 12 and 18 is in proper order. But the unsorted elements are there, 7, 10 and 3. So again we want to do the same process. 0 and 1 we are comparing. 7 and 10 we are comparing. It is in proper order. We don't want to move anything. Then 10 and 3 we are comparing. 3 is the smallest one. So 3 we want to shift it to first position and 10 we want to move to the second position. So we got the third highest element. So 10 is the highest element of this unsorted array. So we got it. So that is also over now. Now only two elements are left, 7 and 3. It is not in proper order. So we want to compare these two adjacent cells, 7 and 3. So we want to move to the positions. 3 we want to move to the 0th position and 7 we want to the first position. So swapping. Now the array is in sorted order. Is it? 3 we move to the first position. 7, 3 and 7. The highest of the 3 and 7 is 7. So we got the fourth highest one. Now only one element is left. So we don't want to swap it. Is it? Yeah. Now see, the array is in sorted order. Understood now? This is called bubble sort. We are bubbling the largest element to the top of the list. Top of the list means at the end of that list. That is bubble sort. Now we got the array in sorted order. Understood? Now we can check how we can write this, how we can solve this problem. Okay? Now we can check the algorithm for bubble sort. Step 1, start. Step 2, accept a value in n as the number of elements of the array. That means we want to input a value in n to show the number of elements. Number of elements means we want to set the limit of that array. Then step 3 is accept n elements into that array. So that much elements we want to input in that ARR. AR is the array name given here. Then in step 4, here onwards our logic begins. So what is the logic here? We want to compare two adjacent cells. Is it? We want to compare two adjacent cells, and if it is in sorted order, if it is in order, we don't want to swap it. If it is not in sorted order, we want to swap it. So that is the logic here. So step 5 to 7 we want to repeat it n minus 1 times. Okay. So what is there in step 5? Repeat step 6. Only this step we want to repeat it until the second last element of the list. Until the second last element of the list. Why second last element? We can check this step number 6. Starting from the first position, compare two adjacent elements in the list. If they are not in proper order, swap the elements. So we are starting from the first position. That means at the 0th position. And we are comparing two adjacent elements. That means 0th position and first we are comparing. If it is in order, we can skip that process, swapping process. If it is not in proper order, we want to swap the elements. Now we want to repeat it. Again we want to repeat the same process. So 1 and 2, we want to compare it. If it is not in order, we want to swap the elements. Then 2 and 3, then 3 and 4. Like that we want to keep on doing this swapping process. We want to compare and swap it if it is not in proper order. Until the last element, until the second last element. Why second last element? Because if the position is at the second last element, we are comparing the next element. Is it? We are comparing two adjacent cells. So our current position is at the second last one. So we are comparing with the last element there. Second last and last we are comparing there. So already we got that element. So we don't want to check with, again we want to continue with the last element. We can stop there when we reach at the second last element. Understood? So that is step number 6. Then in step 7, revise. Now we got the highest element. Now we bubble that highest element to the last position of that array. Again we want to revise the same step because only the highest element we got at the ending position. Now unsorted elements are there. So we want to do for that elements also. So revise the list by excluding the last element in that current list. Okay, because the last element is the highest one, that is in sorted order now. So only the remaining part we want to swap it, compare it and swap it. So that is bubble sort logic. So after this process we can print the sorted array AR. Understood now? So what is bubble sort? We are comparing two adjacent cells, and if it is not in proper order we want to swap it. That is bubble sort's logic. So after doing all this process, one passes over means we got the highest element at end. So that is in sorted way. The next remaining part, from the 0th position onwards, we want to do for the unsorted elements again. So again we will get the second last one, second highest one, that we want to set at the second last position. So again for the remaining part. So this process will continue n minus 1 times. Got it? So after this process we can print the array. So this is the algorithm for bubble sort. Now we can check how we can do it in C++ program. Okay. So here C++ begins void main, then int AR of 10, AR is the array here, 10 is the maximum size, n is the variable given for the limit of that array, then int I and j are the loop control variables, and temp is the variable for swapping purpose. Okay, now see out how many elements you need. This is the prompt we are giving for the user. See in n we will get a value there, that is the limit of that array. Then see out, enter the array elements. So next we want to input the elements in that array. So we are giving a prompt to the user, enter the array elements. Now we are inputting to the AR array. So for loop begins, I is equal to 0th onwards, I less than n, I plus plus, C in AR of I. So we set the array now. Okay, see this here, array, AR is the array, elements are there, and see the index number, maximum size is 10, and 1, 2, 3, 4, 5 elements are there. So here n, in n we input 5, so 5 elements are there in the array now. Now it is not in proper order, so we want to make it into ascending order. So our logic begins, bubble sort logic begins here. For I is equal to 1, I less than n, I plus plus. For loop begins, I is equal to 1, I less than n, I plus plus. Okay, why I put 1 here, I will show you in the next loop. Here we want to repeat the process how many times? N minus 1 times. Do you remember in the algorithm? N minus 1 times only we want to repeat this process. If 5 elements are there, we want to repeat only 4 times. Okay, only 4 passes are needed here. So for j is equal to, how we can pass the elements? Okay, for j is equal to 0, j less than n minus I, n minus I. This loop is using for the step number 6. Do you remember that step number 6? Yeah, what is there? Until the second last element we want to compare it. Is it? Until the second last. So how we will get second last one? Yeah. See, j less than n minus I. I is 1 here. N is 5. 5 minus 1 means 4. So j less than 4 means 4 is here. J less than 4 means 3. So index number 3. So in the index number 3 is the second elements. So we want to repeat until this position. Okay. Now what we want to compare it? If AR of j is greater than AR of j plus 1. So this is the comparison of adjacent cells. So J is 0 now. So AR of 0. Is it greater than AR of 0 plus 1? That means AR of 1. 0 and 1 we are comparing. AR of J means AR of 0. AR of J plus 1 means AR of 1. So 10 and 7 we are comparing. So here 10 is the greatest one. So this condition is true here. Is it? So if it is true, we want to swap it. So how we can swap the elements? So we need a temporary variable there for swapping. So temp is equal to AR of J. So this 10 we are moving to that temporary variable. Now AR of J, in AR of J we can copy that J plus 1 position value. So 7 will move to the 10th position now. And then in that 7th position, that means the index number 1 position, we can set the temporary value. So this is the way of swapping. So 7 we are shifting to 0th position and 10 we are shifting to 1st position. Because here AR of 0 is greater than AR of 1. Okay, so we want to swap it. So swapping is over now. So 7 and 10 we moved. Okay, now again we want to move to the next element, that is J plus plus. J plus plus means J is 1 now. Now next is 1 and 2 we want to compare it. So is it less than 4? Yeah, it is less than 4. So 1 and 2 we are comparing. So 10 is there in 1 and 12 is in 2. 10 is not greater than 12, is it? So we don't want to swap it because it is already in swap style. It is already in sorted style, is it? No need to swap again. So 10 and 12 is set. Now J plus plus again. So J is on 2 now. Okay. Now we want to check 12 and 18. 12, AR of J is 12 and AR of J plus 1 is 18. We are comparing this. So 12 is the smallest one. So this condition is false. Now we are moving to the J plus plus position. So we don't want to swap it. So 12 in the same position itself, 18 also in the same position. Now J plus plus. J plus plus means J is on 3. Okay. So AR of 3, is it greater than AR of 3 plus 1, 4? Is it greater than 18 and 3? 18 and 3 is comparing. Is it greater than 3? Yeah, it is greater than. So here we need a swapping. Is it? So 18 we are moving to the temporary variable, and in that position, that third position, we are moving the 3. Then in the fourth position, we are moving the temporary value, that is 18. So swapping. So 3 moved to here and 18 moved to here. Understood? Swapping is over. Now J plus plus. So the comparison, see the comparison? J is less than 4. J is 4 and minus 1 is also 4. So the loop ends here. That means, so one passes over. One passes over, one iteration process is over here. So after this iteration, we got the highest element in the top position, at the last position. Understood? Now we want to repeat the same process again. Only the 18 isn't sorted now. Again, we want to do the same process from 0th to 3 because this is the unordered list now. So we want to find out the highest and we want to bubble that value to the last position of this unsorted array. That means the second last one. Okay. So the same process begins. J equal to 0, J less than n minus I. I is 2 now. So we can skip this one and this one because this is the second last element of this unsorted list. Okay. So n minus I times. Now we are checking AR of J and AR of J plus 1. 7 and 10 we are comparing. It is already in sorted style, so we don't want to swap it. Now 10 and 12 we are comparing. We don't want to swap it, it's already in sorted. Now 12 and 3. So 12 and 3 we are comparing. So 3 is the smallest one. So we want to move to the second position and this 12 we want to move to the third index position. So 12 we got the highest one. Is it? The highest element of the unsorted array. So we got 12 also. Now 12 and 18 is in sorted order. Again, the second pass is over. Second iteration process is over. Now I plus plus. I is on third position. Okay. Now repeating from the 0th position onwards. So 3 elements are there remaining. Okay. And the second element is 10. So till this only we want to do, so only 2 times. So 7 and 10 we are comparing. No need of swapping there. Then 10 and 3 we are comparing. Yeah, 3 is the smallest one. So we want to exchange these values. So 3 to the first position and 10 to the second position. So this also swapped. Understood? 3, 10, 12, 18. Now in the unordered list, 10 is the highest one. Okay, now 10, 12 and 18 are sorted. Now we want to check only that 7 and 3. So only one time we want to repeat this process. So again j is equal to 0. J less than n minus I means only one time we want to do this. We are checking 7 and 3 now. 7 and 3. Yeah, 7 is the greatest one. So 3 we want to move to the 7th position. Is it? Yeah. 3 we want to move to the 7th position and 7 we want to the index number 1 position. So 7 and 3 is sorted. Now I plus plus iteration, the last process is also over now. The condition is false here. We don't want to do any comparison. It is over. Now see the array 3, 7, 10, 12, 18. Now all the elements are in sorted order. Understood? 3, 7, 10, 12 and 18. Array is in sorted order. Got it? Now we can print the array I is equal to 0, I less than n, I plus plus. AR of I means we will get all the elements in the sorted style. Understood now? So this is called bubble sort. So only the process is, see here, I is equal to 1, I less than n, I plus plus. Inside that, j is equal to 0, j less than n minus I times. I times only we want to repeat this process. I is incrementing there. So we can reduce the step 1 by 1 here. Okay, that's why I put I here, n minus I times. If I is 1, 1 we can skip. If I is 2, the last 2 elements we can skip. If I is 3, last 3 elements we can skip. So that's how we can put the condition here, j less than n minus I times. Okay, clear now? This is called bubble sort. I hope you all understood the concept of bubble sort. So see you in the next video with a new topic. Till then, take care. Bye. Thank you all.